So we already kind of mentioned energy transfers, but one important concept to highlight here is a principle of conservation of energy. And this basically states that energy can be transferred usefully, stored or dissipated, but the key thing is it cannot be created or destroyed. And what that means is that if you have a closed system, that means your energy doesn't escape out of your system. What happens is the net energy change is always going to be zero. And so essentially what that means is that you can convert between different types of energy when you have a closed system, but the total energy at the beginning is always going to be equal to the total energy at the end in your system. Now, this is quite important to understand because a lot of the time we talk about wasted energy, but wasted energy is sometimes we say we've lost energy, but actually, according to the conservation of energy, we can't lose energy, it can't be destroyed, the energy is still there. So what we're talking about when you say energy is wasted is converted into less useful forms. So you've already seen it before, the energy can be transferred into lots of different energy types and energy stores. So when we have energy converted into less useful forms, that's what we call essentially wasted energy. And a lot of the time, the energy is dissipated into the atmosphere. That means that the energy essentially spreads out into the surroundings and is not contained within our initial objects. And a really good example of this is when you have friction between moving parts. So if we were to draw two different gears together, in fact, I'll just draw a chain like this. Let's say you have an interlocking chain like this. And the idea is that between the teeth of your chains, what's going to happen is you're going to have some friction. Okay, so imagine this one is moving this way and essentially they're moving together, but they're kind of moving over each other. And in this system, what you're going to have is friction. And so what ends up happening is a lot of the kinetic energy from your chain. So let's imagine this is like a factory line or a factory belt. Then the kinetic energy would be converted to thermal energy, and that would be kind of dissipated into the surroundings. That thermal energy would heat up the air around it, it would heat up the belt itself as well. And essentially this is what we term the waste energy. This is the energy that's converted into a not very useful form. And so one way that we could actually reduce the transfer of energy into less useful forms is to use lubrication in this case. So when it's due to friction and you're generating this thermal energy, then the way you could prevent it or reduce that wasted energy, if you like, is use a lubricant. So something like oil or WD-40 between these two moving parts would cause them to move more smoothly over each other, reduce the friction, and therefore reduce how much energy is converted to the not very useful thermal energy. Another example is when you're heating something up. So if you go back to our example of the kettle, or in fact, we'll use a fire instead. So let's say you have a fire over here. So this is my fire, and you're going to have a pot of water on your stove. And the idea is that in your stove, in your pot, you've got this water, but the fire itself, some of the heat is being transferred into the pan, but a lot of this heat is being dissipated outside as well. And in fact, a lot of the thermal energy from the pan is going to be dissipated into the surrounding areas. And that's again not very useful because we're trying to heat up the water in the pan, but instead our thermal energy from our fire is being dissipated into the area around the pan and around the water, which is not what we're trying to heat up. So that again would be wasted energy. So in this case, what you could do is add a layer of insulation. So if you were to put a layer of insulation all around the pan, what this does is this prevents so much heat being lost and conducted through the actual material of the pan, and therefore you reduce the amount of thermal energy that is dissipated away from the pan, and you keep more of it inside of your pan to heat up your water, and therefore you're reducing the amount of energy that's converted into less useful forms, or in this case reducing the amount of energy that's dissipated away from your actual water. And we do want to look at thermal efficiency in particular in a little bit more detail. So thermal efficiency is particularly relevant when we look at the heating of homes. So let's say you have a building like this, and this is the inside of your home, and your home is made up of these walls. So let's say you have a home like this, and we're going to draw the wall of our home. So the material of your wall itself will actually dictate how much energy is dissipated away. So imagine you have a heat source inside of here. So this is giving out heat. So we'll just label that your heat source. And if you're trying to keep your home warm, then what you don't want is this heat traveling into your walls and then being conducted outside, because that essentially is the heat dissipating. That energy is being dissipated outside of your home, and you're losing it from your home. So this is not useful energy. So how could we reduce that? Well, there's two ways that we can actually prevent this. So the first one is the thickness of your walls. So when you have thicker walls, what that does is it reduces the amount of energy that can be conducted through the walls so easily. And to understand this, we introduced this term called the rate of cooling. the rate of cooling refers to how quickly you can remove that heat and how quickly the building will cool down. So when you have a thicker wall, you increase this rate of cooling. Okay, so this would be higher when the thickness is higher. The second factor is called the thermal conductivity of the walls themselves. So the thermal conductivity refers to how easily or how good a conductor the material is. So much like we have the specific heat capacity of every different kind of material, all materials also have a certain thermal conductivity. So if you build your walls with a material with a really high thermal conductivity, that means it's going to conduct a lot of heat away from your house and dissipate a lot of heat outside of your house, and therefore the rate of cooling once again will also be higher. So both of these, and you have a high thermal conductivity, or you have, this should be if you have less thickness in your walls, so thinner walls, that means the rate of cooling will be higher. Okay, so the two ways that actually you could reduce the rate of cooling, if you wanted to reduce it, you would have to use a material in the walls with a lower thermal conductivity to prevent so much heat being conducted away, and you would use thicker walls, as that would also prevent so much heat being conducted away and reduce the rate of cooling. Okay, so basically be the opposite of this what we've drawn here. And there are also various other ways to insulate a house, things like adding loft insulation, adding carpet, adding double glazing in your windows. All of these things will contribute to reducing the rate of cooling of your home itself. And so this is kind of the key concept. Okay, so let's have a go at a few questions now. Okay, so a few questions here. Feel free to pause the video and have a go yourself. And let's go through the answers now. Question 1, how do you reduce unwanted energy transfer of a bike chain around a gear? Well, the idea is you want your bike chain to move around the gear, so you want the kinetic energy. But whenever you have contact between two different moving parts, or one part and one stationary part and one moving part, there's always going to be friction. And so how do we reduce friction? Well, we always want to use a lubricant. Okay. Generally, we want to use a lubricant. Obviously, in some situations, that's not appropriate. For example, in brakes, you don't want to use a lubricant because you do want that friction. Question 2, having a high thermal conductivity means what? Is it A, the rate of cooling is lower, B, heat is not conducted as well, or C, heat is conducted easily? The rate of cooling, if you have a high thermal conductivity, would actually be higher because you're going to lose more energy easily because you're going to conduct the heat more easily. So it's actually C and it's not B or A. Okay, so hopefully that makes sense, and I'll see you in the next one.